caverns old, we must away ere break of day to find our long forgotten gold.
So in a golden age, people would basically lounge around in the nutty, eating food off of the trees and just finding it wherever it fell. The idea of golden ages came from writings of people like Hesiod, this Greek author who wrote about a golden age, a silver age, a bronze age, a heroic age, and an iron age. He would have been aware from the epic poetry of the time of a much earlier age in which the heroes would have used bronze. They'd have had bronze armor and bronze weapons, and they talk about these in the poems. And so they would know that there was actually a bronze age before their present age, the iron age, the less nice age, as far as they were concerned. And so then it would be logical to think that before the bronze age, bronze being a more valuable material than iron, there was a silver age being a naturally more valuable material than bronze, and before that probably was a golden age. The golden age would be the nicest age. The Roman author Ovid used the same sort of idea, and so in the golden age people basically did hunting and gathering, shall we say. In the Silver Age was the beginnings of agriculture. The Bronze Age, people farmed widely and you started having bronze weapons. And in the Iron Age you had great empires and people being very mean to each other. That was his idea. A slightly earlier author from the Roman world was Lucretius. And he had a completely different take on it. He thought that at first humanity fought with hands and nails and teeth, and then progressed to stones and branches torn off trees, and then copper and bronze, and finally iron took over from copper and bronze. So this is basically a progressive perception in which things get better with time. Completely opposite to the Golden Age theory of earlier or other authors. This is C.J. Thompson, the very important Danish museum curator. This is him, you see a happy smiling face, talking to the public about the artifacts in the museum. I kind of identify this with myself. So I have a lot of enthusiasm for C.J. Thompson. He divided his collection, being the original concept of what a curator was, which is someone who looked after things and ordered them rather than moved them around like buns in a bakery. Stone Age, Bronze Age, and Iron Age is how he classified his collection based on the material things like the weapons and tools were made of, and he considered this to be a chronological progression, although the actual dating is something he often bewailed the inability to create. But certainly as a relative dating concept, it is something that has continued to the present age. There have been modifications. I would suddenly have a Chalcolithic, for instance, and there are many subdivisions of these now, but still basically we have the Stone Age, Paleolithic, Mesolithic, Neolithic, that sort of thing, the Bronze Ages, and the Iron Ages, and that's how archaeologists are looking at the cultures of the past to this day. So why it's important to bring this up now is because we're just going to start talking about metals. And you can see out of these three ages of humanity, two of them are metals. And so you may wonder, why is it so important to classify things by metals? And it's difficult to see, really, in many ways, because archaeologists in the present day are more likely to use pottery to classify, certainly after the Stone Age, and before pottery, the stones would be perfectly acceptable. But after that, we typically use pottery to say, oh, this is a Middle Bronze Age 3 site or something like that. And so Thompson didn't use pottery, but it's possible it might be because bronze and iron or something was far more collectible as artifacts and were an important part of the collections. So, metals, very important. Metals come from ores. So we talked a bit about ores earlier on when we were talking about minerals, and I showed you some very important ores of the various metals that were used in the ancient and medieval and prehistoric world. There are two types of ore deposit. There is the primary deposit, still in the rock in which it was emplaced as a mineral. And this may be in a vein. See, this is a vein going through the country rock. And there are secondary deposits, which are from the weathering down of the primary deposit into, this is a gravity deposit, it's just sort of falling down the hill, and can also be moved around by a stream, which is called a placer deposit. And so you have these two main types. You have primary and you have secondary deposits. This is a mine. So this is a very early type of mine. Of course, when humans first started thinking, oh, that material there looks useful, I can make something with that, it was sitting right on the surface. And so you would have the mineral deposits just right there on the surface. And sometimes it's even easier to notice than it is when it's underground, because it will oxidize or be modified into more brightly colored minerals. And we'll be talking about that a bit more when we get to copper deposit later on. But once you've exhausted that surface deposit, you will find that the mineral will often go into the rock. See, this is basically, they have a vein of some intrusive material here which had the ore in it, and they have followed it down into the hillside, following the load being the deposit of the ore. They may do some of this, or in early days, with a mole like this, a rock just put together with sticks, and you just bang away at the rock until it basically reduces. And we saw something like that when I was showing you quarrying in Egypt. Very useful for an economical way, if you have free labor or cheap labor, of reducing a rock is to hit it with another rock. Another idea is to actually set fire to the rock. Of course, you can't typically set fire to rocks, but you can pile wood up against it and then set fire to that. And that will make it a lot more friable and more easily broken up with whatever tools you have to hand. This is what fire setting looks like. So you see it has a very smooth appearance from essentially having fires put up against it and then hit with moles. This, however, is also the side of a mine, and here you can see pick marks. And you can even see two phases of pick marks. You can see this very fine work here, possibly with a small pick, possibly made of a more valuable material like bronze. And here you have much heavier picks, perhaps an iron or steel pick being used to quarry into this mine. So once you get your material, you have acquired your raw materials, you will need to process them. Processing is a very important part of metals. It's been a very long time since you could pick up a metal from the surface and work it into something. So this is often called in the ore processing business benefication. Benefication, which means making things good or better. So the first thing you do is sorting. And so, of course, when you're mining, you're just like whacking away, and there may be some division right at the rock face of differentiating between rock and ore, but most of it is actually done when you get to the surface, and you will start saying, oh, that's got a lot of ore in it, and oh, that one doesn't. Another thing you want to do is crushing it. So you'll be getting big bits of rock out, only some of which will have ore in it. And so if you crush it, you'll have more ore in the rock. And here you have these young chaps in South Africa just banging away with a hammer. And this chap has a foot-powered hammer, in which he stands on it, and it goes up, and he gets off it, and it falls down and breaks rocks. Another thing you can do is washing, often known as panning or sluicing. This is obviously panning. See, this person is panning for ore in this stream. Sluicing is if you set up a stream in order to separate the ore from the rest of the rock. And this works because a lot of ore minerals are heavier and denser than the rock you find them in, and so they will separate if you sluice water around in them. Here we have what appears to be the same sort of thing happening in Egypt, and here they're using a hide to sluice backwards and forth to the water to separate ore minerals from the other minerals it's a part of. Roasting is another important part of processing the ore. And this is very simple, and you can see what it is. You just build a fire and put the ore on it. So this is called heating in oxidizing conditions, and of course it's oxidizing because it's in the open. It's as simple as it looks, because you need the oxygen. The oxygen helps break down the ores into more usable materials. It makes the basic rock material more friable, just as it did when you were fire setting in the mine. And a lot of the minerals, and you remember things like sulfides, chlorides, and carbonates from the mineral section, it'll convert them to oxides, which are an ore deposit which are more easily dealt with, just the sort of thing to put in your smelter. And it also drives off water, which is also not very good if you're going to smelt it. So after that, you might put it in a smelter, and we'll be talking a bit more about that when we get to other materials. And in this, you melt the material, hopefully, if it's something you can be melted. Iron, for instance, is a very difficult thing to melt. And you create a raw material you can work with. As I say, more about that when we get to other materials, because at the moment we're going to talk about, we're actually going to talk about this. So this is another source of raw materials. It may look like a very large man with weapons getting attention from very little men, and they're sort of like scraping at him. And this, on the same vessel, may look like a very bad scene, where this chap is knocking this chap's head off, and there are hands and feet, or actually maybe they're both feet, hanging off the wall. It sounds like some horror story, but in fact it's a foundry. So this is called the Foundry Cup. And here you can see what is happening is they're recycling statues. It's horrifying to think that some of the beautiful objects that existed in the past have been broken down and melted and turned into something else, possibly something not as beautiful. And so here we have the material being melted, and this chap has got the bellows at the back. And so this is a very important source of metals throughout the history of metals, is recycling. So those chaps were recycling. This chap, this is from one of the Wolf images from his book. We have here, you can see they had sheets of some sort of copper alloy, and something had been cut out of it. So this is like waste from the manufacturing process, but also there's a lot of vessels here. See, all these dusty vessels, these haven't been made. They are ready to be thrown into the pot to be recycled and reused. See, here's a big dish or something. And so there's all of this would go in. There's no waste in the past. Once you have a metal artifact, you only do something important with it. You may bury it with somebody, or you will pass it on to somebody, and if you don't want it anymore, you don't just throw it away like a broken piece of pottery. You melt it down. And the overwhelming majority of the artifacts in the past made of metal were melted down or reforged into other objects. And so we actually have a limited amount of those things, or those objects. That stuff, I should say. So, gold. I'm going to talk about one metal, partly because it's just so shiny, and partly because it helps to sort of focus what we're talking about as we move into manufacturing. And that metal is gold, because it's all about the golden age. So, gold forms in veins of quartz, called hydrothermal veins, because they are thermal, in this case very, very hot, and they are hydrous, they have a lot of water. And so this is right at the end of a lot of rock emplacement. You'll have these hydrothermal veins breaking through the country rock, leaving quartz behind, and in some cases, gold. So gold, as I mentioned earlier, gold does not combine with oxygen or sulfur, so it's always found in the native state. Remember native minerals, and also oxides and sulfides, and gold is only found as a native mineral. However, in the natural state, it is always alloyed with certain other metals, such as silver and copper. An alloy is like a rock is to a mineral. So if you have the mineral gold, you'll find that it makes something like a rock, an alloy is like a rock, and other minerals in the alloy are silver and copper. And they tend to also, in this state, be native silver and native copper, but they're closely intergrown with the gold. And so it's better at early times to think of it as being one metal. This metal is actually called electrum. And so all ancient gold, very ancient gold, I'll tell you when it stops being electrum, is actually got a lot of silver and copper in it. Typically, electrum is 5 to 50% silver. And of course, you can also have copper in it. So there is a lot less gold in very ancient gold than you may think, such as this chap's mask. So gold has a very high atomic weight, which means it's very heavy. And so the mechanical means of separating, such as the panning, have always been important from ancient times up until the present. So panning for gold is what you do. So this is what gold looks like when you find it. This is actually a wreck site where near Caesarea in 2015 they found 2,580 Fatimid gold coins from the mid-9th to the early 11th century just sitting on the surface. And this is what they look like when they come out of, well, the sand in this case. And this is what gold will typically look like when you find it. When you find gold, you think, wow, that is amazing. Because, as I've mentioned, everything else oxidizes or will convert to some other material. But gold is always gold. And so, you know, any self-respecting archaeologist tends to not have a lot of respect for gold because, after all, it's just a shiny material that people think too much of until they find it. And then when you find gold, you think, wow, that's amazing. It looks exactly as it did when the last person to own it left it. I have only found one gold artifact in my life, a gold ring, which I found on an archaeological site. And it was quite amazing to realize that it looked exactly as it did on the day that the person dropped it. and lost it. They were probably very sad. So here is Reef Gold. This is the primary deposit of gold. And here it is, still within the matrix of the quartz veins. Here's another quartz vein with no gold in it, in the country rock. So that's what Reef Gold looks like. Also looks a bit like this. This is like a close-up. This is actually not Reef Gold, because this is a rock, a cobble from a gravel deposit. But you can see how the gold is emplaced around the quartz. So placer gold is the secondary deposit, typically found in very rapidly moving water in gravel beds, often associated with other heavy minerals such as magnetite and cassiterite. So they're found in gravel because they are so heavy. It takes a lot of water to moving very fast to move these at all, and so they're deposited quite easily, and you find them in these gravel beds. They can also, the flakes can also join together to form what is known as a nugget. So this was what a nugget was before they started calling chicken things nuggets. Placer gold can also be in deposits which are buried and become indurated as rock, which must then be mined. So an ancient, say, Precambrian placer gravel can be deposited under the ground and have other rocks put on top of it, and after millions of years become solid rock rather than just gravel with gold in it. So in that case you need to mine it. So all secondary gold will often have tin and platinum group elements in its chemistry, and so when you analyze it you can see the difference between primary gold and placer gold. So the sources for gold in the Middle East. So it doesn't appear to occur anywhere in Mesopotamia, Syria, or Palestine. There is some evidence of west and southwest Anatolia, western and southern Arabia, northern Iran, Transoxiana, so over in the east, Afghanistan, up in the mountains, have some gold. But at Egypt was the main source of gold in the ancient world, and there are three very productive regions. There was the gold of Coptos from the eastern desert around here. There was the gold of Wawat from the Alaki and Gabgaba wadis going into the Precambrian shield over here. And the gold of Sudan and Ethiopia, the gold of Kush. So again, see, this is there's a Precambrian shield here, and this is where they find gold. This is where most of the gold in the ancient world probably came from. It's something that other rulers around the known world, around the Middle East, would always be asking of the pharaoh, have you got any gold? Because they liked gold. It was very shiny and made them feel good. So this is where I'd like to bring up the idea of a carat, partly because somebody once asked me, what is a carat? So I had to look it up. So this is a measure of gold purity, and it's from a weight. It's originally from the Arabic, being the fruit of the carob tree, a weight of 4 grains. It was a unit of mass. So a carat with a C is a unit of weight for diamonds and other gemstones. So 1 carat equals 200 milligrams, whereas a carat with a K, used for gold, is a unit of purity. So 24 karat gold is pure gold, whereas 18 karat gold is 18 parts gold, and typically 6 parts copper. So that's what carats are, not the vegetable, of course. So once you have your gold, or other castable metals, you might want to cast it. So you will want to turn it molten. And so here we have these chaps. They they have this little furnace going on here, and they have, these are foot bellows, and they're going up and down, making this hot and melting this this metal. And it is thought that this, whatever is going on here, is actually what it looks like, and this is some clue to how molten it is. And so they take this from there and they pour it into the mold. And this seems to be what they're making. These are doors, golden doors. Or maybe they're making bronze doors. I don't actually know. The most common ancient way of making casting metal objects is using the lost wax method, in which you make an object out of wax and you put it in clay or some material like that, and then you melt out the wax and you're left with a void in the shape of the thing you want. This is a very easy technique, and anybody can do this. Just wax, make your thing, stick it in some clay, heat it up, this becomes solid, this goes away. You pour the metal in it, and for something that melts at quite a low temperature like gold, this is quite easy. Then it hardens, you break it, boom, break it, and you are left with the thing. And this spur here needs to be broken off. You might polish it up a bit, and there you go, you have your ring. So this lost wax method is very simple and very popular in early times, and up until the present time, in fact. If you want to make a unique thing, if you're making mass production, you will want to do something like this, which is using a mold, a two-piece mold in this case. So here you can see there are two parts of this mold, and he will put them together like these two. They're all bolted together, and you will pour the molten metal into one end. So here he is pouring the metal into these molds. So the risers are those spurs of metal that are from how you get the molten metal into the void where the object, the future object, will be. And so these will all need to be cut off. See, that's what this chap's doing, and will then need to be polished and try to make them look as though they were never there. Typically you can see where they were there, and so this quite often is a way you can see. You can usually see the seam where the part mold went together. And when you see a seam, you know that this was a part mold and not lost wax. And so you often find there are artifacts which are fakes because they have a seam on them and typically should be lost wax. This is quite a nice little mold, which I like because it has arrowheads. It's Neo-Assyrian, and I think it's at the British Museum. I see one just like it at the British Museum. And so this is a multi-part mold, you see. It has a bottom, and 1, 2, 3, 4 parts go into it. See, these little spikes are how you haft the arrow. And you put the whole thing together with this ring to keep it together, and pour the bronze into the top, which is like this end. And that makes the arrows. Isn't that cool? Raising is another technique for manufacturing metal objects, and that's what this chap is doing here. And you can see he has this anvil-like thing. This is actually probably made of iron, or it could be bronze, and he's hammering away at this object. And by this, that's how he's turned what would have originally just been a sheet of metal into a pot, by raising the vessel over this iron, this snarling iron. Like this. This is the snarling iron. And you see, like that ancient Egyptian one, this is from Wolf. This is another anvil, which would probably be hammered into another piece of wood. But this is very common for trying to raise vessels, which you want to put over this projection that goes into the vessel. And you can see it's actually quite flexible because you can turn it over and then use this bigger end. So it has two ends, and you just turn the wooden part over to do it. And unlike the Egyptian one, this is designed to be steadied by being sat upon. So here you can see this chap is sitting on one. So here's the iron going underneath and into the pot. And so he's banging away, making an object. So you might want to decorate it by embossing. So here you can see this chap is hammering away on the outside to create a design on it. That's what this chap is doing, exactly the same thing. What he will typically do is fill the vessel with pitch, and that makes it less easy to dent, and it'll just take the impression you want to make as you emboss. So soldering is very important, and it's very easy to understand when you get to gold artifacts, because soldering is when you have another material which melts at a lower temperature and you fix two parts together. So with soldering gold, you add copper. So this is an example of a late period Egyptian artifact, which had 92% gold, 7% silver, and 1% copper. The solder was 55% gold, 18% silver, and 27% copper. So a lot more of copper in it. So pure gold melts at 1,000 degrees centigrade or so. When you add 10% copper, it will melt at 925 degrees centigrade, so that's much lower. 20%, which is getting close to this, is down to 880 degrees centigrade. So you can see how a solder, some metal with more copper in it, will melt at a lower temperature. And so you can join parts together without melting the whole thing, because the part that joins them together melts at a lower temperature. Granulation is a part of that. This is an object which has granules fused to the surface, little balls. You see all the little balls? And they do this by using glue and malachite. You may remember malachite as being a copper carbonate. So what you do is you put the balls on with glue and malachite, and once they're all glued on, you heat it up. And so what happens is that the glue itself burns, the carbon goes away, but the malachite reduces to pure copper. And so the copper will fuse the gold balls to the surface of the gold artifact. And this is granulation. Gilding is also very important. So this is sheet gold or gold leaf. Gold leaf is under 1 micron. This must be glued to wood, and traditionally this is done, and other materials, and this is traditionally done with egg white. So this lady has been gilded in that manner. A silver or copper surface, and of course silver and copper like to have gold. They're found together in their natural state. So in that case, you just clean it and put the gold on it and burnish it. You just rub it in and it's fine. Or you could also heat it, and that's called diffusion bonding or cladding. You also have mercury gilding, which you take gold dust and mercury, and you heat up the gold paint to vaporize the mercury, and this was started in the 4th century BC. Now, of course, having mercury vapor would have been incredibly toxic, so ill-advised. Here we have these chaps are making gold leaf. You see, they have these very large hammers, and they're pounding away at the gold leaf, making it nice and flat. This chap is ornamenting a steel artifact, looks like a deer, with gold. He uses gold wire, and so he creates an indentation and then bangs wire into it. And then he's burnishing the surface to make it flat. that is actually how this is made. This is something I looked at with a digital microscope, and you can see how this steel blade has had this line chiseled out of it, and then gold has been inlaid along the line and hammered in, and then burnished on the surface. So it's a common way of gilding artifacts. Cementation. Cementation is very important. Cementation is a solid state process. There are other forms of cementation in materials manufacturing. They're all solid state processes in which things go from one thing to another while being in a cement. In this case, we're talking about how to separate gold and silver, which, you know, when you have electrum, you want gold and you want silver. It's what you want to do. So this uses chlorides or sulfates to create a silver chloride or sulfate. Because the silver, although it likes gold, it would rather be with chloride or sulfate, which is fine, I suppose. But this only works on the surface. Most cementation techniques will only work on the surface. And so it's at first could be used for a surface enrichment, or can be used on very fine material. However, the mass turning of electrum into gold and silver started off apparently in Lydia, in modern Turkey, at a place called Sardis, which is interesting because the history books told us that, and the archaeologists seem to have supported it. Excavations there found the late 7th century BC. A major gold strike in the river meant that they started making a lot of coins. The early coins were made of electrum, but by the mid 6th century BC, they were making pure silver and pure gold coins. So at some time they had worked out how to separate them. And so these people went and excavated Sardis and found out how they did it. Now, this is actually to do with this man, Croesus, renowned for his wealth, which the words here are actually covering, but Croesus was known to Herodotus as being incredibly wealthy, and he ruled Lydia from 560 BC until he was defeated by the Persians in the great Achaemenid expansion westwards. And Herodotus says that the Lydians were the first to know how to make coins and making gold and silver currency. And so this is why we have the term as rich as Croesus, because he was so very, very rich. And that's probably why the Achaemenids came and conquered Lydia. So this, although we have no contemporary Lydian reference to this chap, this is exactly that time. So this is what Herodotus is talking about. So here we have an excavation in Lydia with this pot in this oven. So what they did is they took the electrum and beat it into thin foil. So this basically exposes the maximum surface area, because you need to expose as much surface as possible, because, as I said, cementation is always something that happens on the surface. And they put it into a parting vessel. This is the parting vessel. And so this is actually just a cooking pot, but it's packed with cement, as in cementation, with salt and some silicate material. So you remember what salt is: sodium chloride. And what does silver like to be with? Chloride. So the pot was then put in a small square furnace, there's the furnace, and heated for an extended period at dull red heat. Later on this happens for several days. That may have been what they were doing in Lydian times. So after this, the silver has all passed into the cement, and you have gold and you have silver. So making wire is very important. It's important for gold and other more precious materials, but it's also very important for iron and copper. But we'll talk a bit about it here. Wire is actually very difficult to make. One way you can make it is by hammering it. So basically you have a bit of metal and you keep hitting it with a hammer until you have wire. Yes, very difficult. And you have block twisted. And this is actually what these images show. And so here you've hammered it a bit. This is the wire before you start twisting it. And you twist it and you roll it between two blocks until it gets more twisty and more rolled, and you end up with wire. A lot of ancient wire is made this way. You also have strip drawing, in which you create a strip of the metal and then you draw it through a hole until the strip rolls in on itself, making basically a hollow wire. Then you have strip twisting, in which you take a strip and then twine it around pre-existing wire. You then take out the pre-existing wire and you just have the twisted wire. So in the medieval period, wire was made by just drawing the metal through progressively smaller holes until you had wire. But this is medieval. It's much later than a lot of the ancient wires you might come across. And so here you can see these will be a hard metal. These bars with holes in, and you have these clamps which pull the wire through ever reducing holes, and you can see it takes a lot of pulling to pull back this wire through all the holes. And here you can see here's another device for pulling wire through holes, and here's another one. This is probably much finer now and softer material perhaps, where you're just putting it on a coil, then you put it through another smaller hole, then you put it through the other way. So this is how a lot of later wire was made. So gold is, as I say, very shiny and very popular with people. People who want to show off their wealth, and people are happy to own a lot of gold, it seems. It's one of the great driving forces of human endeavor in the past, as it is today. Whereas today people like to have shiny cars. In the past they like to have shiny bling. It's all about the bling. They probably like to have nice cars too, but you know. This is the earliest major gold hoard in the world, is actually from Bulgaria, from the 5th millennium BC. And you can see he's quite happy with it. Sometimes you see a skull and they don't look happy, but this chap does look actually quite happy, and he should be happy with all. He's taking all this with him, and he still has it, of course. He's in a museum with it all and is still happy. And this is what it all looked like. A lot of gold, you see. Pawabi, of course, also took a lot with her. We don't have her, fortunately, because she was squished. But her headpiece is very nice, very gold. The Oxs Treasure is one of the great treasures of gold in the Middle East, from the 5th, 4th century BC, from Tajikistan. This is a chariot from it. This is an armlet from it. You can see it's very nice. And this is a gold plaque. Don't know what it's for, but very nice anyway. And this is another person that took it with it. Took her gold with her. She was actually had it in a bag at the time, and she was wearing some rings on her fingers and had some earrings on, but she also had a bag filled with gold. But she took it with her into the archaeological record because she was at Herculaneum in 79 AD and died wearing and carrying this gold. But you can see no matter how a poor state this person is and anything else she was carrying, the gold is still shiny, sitting there right in the dirt. And that is what gold will do for you. Thank you.